This session is going to be, I think it was officially titled Scrubbing Your AJAX. Due to the size of this room and the number of people we have, I'm the moderator. I'm going to do my best to try to keep this more interactive and engaging. So we'll experiment with as we're going through this. If you have questions, raise your hand and we could try to address them in real time rather than wait to the end. If that doesn't seem to be working out, I'll probably just defer questions to later on. We're going to do a quick round of introductions. We have a great panel of different experts from different areas of the field to discuss security issues. To start off, I'm Scott Isaacs. I work for Microsoft. I'm an architect on the Windows Live properties and online services. My responsibility there is for how we build and enable all our AJAX experiences, the frameworks, the security, the performance models, and so on. Historically, if you go way back in time, back around 95, I wrote the original specs for DHTML, CSS2D positioning, and so on. So all that pain you're probably feeling with DHTML, you may be able to point the blame back at me if you want to think back far enough. That's a whole nother discussion for a whole nother panel, though. With that, I'll just hand it on, and we'll do quick intros.
I'm Dennis Hurst. I'm with SPI Dynamics. I'm an engineer there. I was a developer long before I worked for a security company. And we have products that test for web application vulnerabilities. So we focus on sort of the hacker side of the world, helping penetration testers see if you've got vulnerabilities in your website. So I guess I sort of bring more the pen tester perspective to the panel.
My name is Josh Pennell with IOActive. IOActive is one of 3 firms chosen by Microsoft to do the Vista code review. Prior to that, a team of our engineers went down to DEF CON, which is a big hacker convention in Las Vegas, which is, kind of deja vu for me being here right now, and won the event for 3 years in a row, and then asked to retire after that. So I bring a lot of business perspective because I'm tasked with selling security to high-level C-levels, and the bits and bytes too. Thanks.
My name is Daniel Egan. I run a consulting group called Odyssey Consulting in Southern California. We do training and development. I'm an ASP.NET developer, and I'm really tasked with making sure developers care about security, and how to get them into caring about security. So,
great. One of the big things we want to do over the next hour and a half is one, dispel a lot of the myths and rumors and big statements that are often made about security of the web. Help you learn and understand actually what it means to try to build and keep your web application secure in this new Web 2.0 world, and so on. So I'm just going to open it up for the panel with a quick question, a simple question, which is why is security so important in this Web 2.0 space? Whoever wants to jump in.
Do you want to start with the business side?
Sure. Security in the web space is of strategic importance to companies. Companies that are not adopting security or finding their ecosystem, their consumer ecosystem dwindling. Consumers are going to other websites that are more secure and aren't going to lose their data. We've seen companies in the recent past actually go out of business due to data breach, losing what they call PII, or personally identifiable information. And that's not the conversation you want to be having with your boss as they're turning the lights off, is that there was a SQL injection or a cross-site scripting issue, or there's you came out the next thing, dangled AJAX app, and it opened the company up to litigation. So that's why I think it's important.
I think the biggest reasons, or one of the big reasons it's important, is that as people develop AJAX applications, typically the reason you're using AJAX is you want a richer environment, and typically the reason you want the richer environment is because you're solving a more complex problem than brochureware. So you're digging deeper into into your business. You have more complex processes. You want to model those or show those on a screen in a way that you're doing something complex. You're taking tax forms. You're taking complex things and trying to make them simpler. And AJAX is a great solution to that problem, but also it's more core information, or something that's more critical to your business. So whereas if your brochure gets hacked, it's a little embarrassing. Maybe somebody makes fun of you. Whereas if your core business application gets hacked, you lose data, you lose customers, you go out of business. So it's a lot of the same vulnerabilities, but we're going much, much deeper back into the businesses. So a lot of the same issues, but we're going more core into the business. So.
Yeah, I actually have a question for you guys. I can't really see your wristbands, so how many developers do we have in here? Mostly developers. What about decision makers? 1, 2, 3, 4, 5 designers. No designers. Okay.
Good one back in the corner.
Oh,
Designers.
Thank you.
Yeah, I mean, security is important, especially for developers, because as many of you, raised your hand, you know how it is when you're in working on a project. They want it yesterday. So the normal thought process is, I can't worry about this stuff. I have a deadline. They need the code working. They need it working now. So the challenge in security, where I'm coming from with my developers, is how do I get them to integrate the security thought process into their normal development, which is really hard when you have them on deadlines and they're already working a ton of hours already. So,
Well, it was actually very good that we saw the makeup of the audience. We'll work really quickly, get through just a little bit back, and we also will do a pretty good dive then into some of the what XSS is, XSRF, and all that, because I think that would also be very useful. But one of the things that I do like to do before we get into the technical details is just have a quick question about, so we have this newfound AJAX. You see a bunch of scaremongering and so on about AJAX, that, oh my God, it's exposing everything. It's this new great technology that's going to be the end of the web and so on. Is that really so true? I mean, has anything has really changed with this new advent of technology and approaches?
Personally, I think not really. You're seeing is existing vulnerabilities like cross-site request forgery, cross-site scripting, classic SQL injections. People are simply finding new and more creative ways to exploit those. So even if you look at, for example, the Gmail exploit, which was hailed as a AJAX-based exploit, it was actually a couple of other vulnerabilities that simply they were using AJAX or JavaScript for the exploitation, and then using features of AJAX to do some fairly nasty things. But at the core, they were vulnerabilities. They were classic mistakes simply using newer technologies. So it's really a lot of the same problems, just in a new, with a new face. So people are making the same old mistakes that we've made for years. We're just making them in a newer technology.
Yeah, I think that pretty much sums it up. If you put access control logic on the client side and the client's manipulatable, like a browser, you're going to get owned. So, and that's true with AJAX. That's true with 132 coding. It's true in any kind of circumstance where you don't actually control the end device, the client.
yeah, I mean, there's not much to add to that. I mean, AJAX itself, except for the term, has been around for a long time now. So it's not, the security holes that we're seeing is not really anything new. It's just the fact that they tacked the word AJAX on it. So now everyone's like, oh, AJAX is insecure. So
The one thing that we've noticed, take off my moderator hat for a sec, is the big fundamental shift is not so much technology, but it's in the approach that we're using to build our applications. Typically, let's just look at a traditional email app. When you used to do email in the pre-Web 2.0 days, it would go to the server and it would render the results. So the logic that and the APIs that would actually serve that data was sitting behind your firewall. So the attack vector was pretty simple, was only an XSS exploit through the front. Now all those APIs that used to sit behind a firewall are moving to the front of your firewall for more direct interaction. So what's really changing is just the surface, the vectors that people could come into your code. The technology you're using and so on has been around for the whole time. And I think that's kind of where this AJAX stuff kind of gets lost in the mix. Going on, so if the exploits are basically the same, how many people are familiar with XSS? Well, that's actually a good segue then, because we have two very brief slide decks, kind of just to show the two most common attack vectors that you see against these new Web 2.0 applications. And they're extremely important to understand, and more important to make sure you have a mitigation and strategy around how to handle them.
I'm a walker, so I hope you guys don't mind if I'm not sitting in the chair. One of the things I found interesting, I did ask at the beginning, how many of you are developers? And, I'd say 90% of the room raised your hand. But when he asked how many people know what XSS is, or cross-site scripting is, probably about half of the developers raised their hand. Cross-site scripting, like we said already, isn't anything new. It's been around for a long time. If you remember the Netscape days, where we had those lovely web pages where everything was in frames. You had a frame on the left-hand side for your menu, frame on the top. And then a little bit later, JavaScript came out. JavaScript was really cool. It allowed you to, do rollovers and all that cool dynamic stuff that we thought was cool back then. What happened, though, is people realize that they could either open up a web page in a frame, an additional web page in a frame, or in another window, and they can inject script into a different site, which obviously is not good. That's where the name came from, cross-site scripting. They came out with a policy called same origin, which doesn't allow you to do that, so you can't send it from one domain to another. So sometimes there's a little bit of confusion of what cross-site scripting is, because now you can't go across sites in the simple definition of it anyway. But what happened too is why it's called XSS, is that around the same time style sheets, cascading style sheets came out, and they're of course CSS. And there was a lot of confusion what you were talking about when you were talking about CSS, so someone suggested, why don't we call it XSS, and it stuck. So when you hear someone say an XSS hole, this is what they're talking about. The simplest definition of it is, I'm an attacker, and I want you on your computer to run my script so that I can get some information from you. That's a very simple example. What we're going to do here is, what I'm going to cover is some simple definitions of what those are, and we can dive deep into them as we go along. There's a couple different types of cross-site scripting: reflected, stored, and local. So we'll go over what they are and kind of some brief examples of how they happen. So the first one is called reflected. It's also called non-persistent, and it's called those names for a reason. I got a very simple screenshot of what it does. Basically, the hacker persuades a victim to click on a URL link. That's not anything new. The victim clicks on the link, the script is embedded in the URL, and it steals sensitive info. So that's the nice pictorial view for those that like to see stuff. But it's actually pretty simple, at least at this stage, what's going on. So a good example of this is a search page. If you've created your own search page, a simple search is you have a text box, you have a button, a user can put something in the text box and click the button. It's going to go back to your server, and when it comes back, it's going to return two things. It's going to reflect back what you searched for. You searched for this, and it's also going to give you back results. So this type of cross-site scripting, what happens is instead of having a URL that will be sent to my server with, my server, search ASPX, keyword, and have a keyword like, .NET, or keyword like Daniel, or, whatever you're searching for, you can replace that with a script tag. The script tag will go back to the server, and then what happens, just like if you're searching for a regular term, that same thing that you were searching for comes back to your site. But as opposed to the just general word, the script comes back. The script will actually be rendered by the web page, and at that point, I can do a lot of things. I can do keylogging, I can seal your session, I can do many different things that we'll probably get into of all the different things I can get. But this is one of the simpler forms of cross-site scripting. But as you can tell, it's it's kind of on a one-on-one basis, at least at this point. I have to get you through an email or something on my site to click on this link for this to happen. The second type is called, let's talk about defenses first. How do you defend against this? You'll always hear in a lot of different security talks is information is evil. Don't trust anything at all coming to your server. Absolutely nothing. What you want to do to protect against this type of cross-site scripting attack is input validation. So on your server, it doesn't matter if the data is coming from the headers, if it's coming from a query string, if it's coming from a form, any place you want to cleanse it. You want to strip out HTML tags. You want to verify that no script tags are coming through. You want to basically strip everything away that could cause any type of script coming back to your web page. It's probably a good time to talk about, and you guys can jump in on any of this as we all go across too. Whitelisting versus blacklisting. How many of you know those terms? Okay. The way I usually describe this is, if you're going to a club, a whitelist and a blacklist. So for blacklisting, basically what you're saying is don't allow these 5 items to come through, but allow everything else. So if you're going to a club, for some reason maybe you got in a fight way back when and you're on this list, they don't let you in the club, you're out of here. But it's very easy to sneak around back and sneak through the kitchen to get in the club. It's not very effective. Whitelisting, on the other hand, is like a VIP list. So you guys are probably going to a party tonight, and at that party you guys are going to be on a list. Only the people that's on that list are going to get through. That's basics of whitelisting. So at the server side, you designate that only these things are allowed to come through. Everything else I'm going to strip out. That's the basics of input validation and whitelisting and blacklisting. Now, that's stuff coming in. In the last slide, I showed you that the script was going to the server, and then it's going to come back to the web page. And if it's just left as a script tag, it's going to be rendered as script, and it's going to cause all kinds of problems. You can protect coming back as well by using encoding. So encoding is pretty simple. Basically, it takes tags and converts them into HTML. So, scripts have less than and greater than, but when you convert it into HTML or you encode it, basically it turns it into, I don't know off the top of my head, like percent sign GHT colon, which won't hurt you, when it comes back. In .NET anyway, you can use basic HTML encoding, which uses kind of a blacklisting approach that we just talked about. But there's also, up on the Microsoft site, a Microsoft anti-cross-site scripting library that's specifically designed to help you with this. We're not going to dive too deep into it, but that uses more of a whitelisting approach. It's much more restrictive. But these are a couple ways that you can protect from this type of cross-site scripting.
The one that I'm just going to jump in on the encoding. The really XSS originates into reflective nature. You're reflecting some untrusted content that comes into your server and sending it back to the client. When it comes down to encoding, a lot of the mistakes that are made in the Web 2.0 space is not understanding. We're now running a lot of script. And the content that's getting encoded on the client can be encoded either into the script or sometimes into a web page. It's basically being encoded into different contexts. So if you're encoding untrusted content into a URL, you might have to encode that slightly differently than when you encode it into a script. For example, a single quote. If you're writing JavaScript and you're a single quote person, if you're not careful and you don't encode those single quotes, someone could use a single quote to close that script out if you're writing the untrusted content into a script block. However, in a URL, the single quote might be fine. It's the double quote that you're encoding. That's kind of an arcane example, but my point there is a lot of the errors that we have seen, especially even across Windows Live, when we do happen to make these mistakes, and I'll make it clear, you will make these mistakes. There's no perfect way around it. It's just understanding when you do them how to rectify them, is making sure that when you're going to do encoding, that you choose the right one. Are you encoding to put it into an HTML attribute? Are you choosing to encode it into an HTML stream, where maybe you want all your lessons turn to ampersand, LT, semicolons, and so on? Are you putting it into a script where you need to protect yourself against people somehow putting line breaks or close quotes and breaking out of your code into their own arbitrary code and so on? Sorry, jump in.
No, that's okay. And actually, if you want to see a very creative way that someone got around this, how many of you heard of the Sammy MySpace worm? Oh, one. Wow. If you just do a search on Sammy MySpace, you'll bring up the guy's site. Basically, what happened is this guy in MySpace wanted to be popular. How many of you guys actually use MySpace? Just a couple. Okay. Well, basically, you collect friends, and he wanted to have more friends, so he wrote this script, and I'll be brief on this, but he wrote this script that did a couple things. What it would do is, on your page, you would inject a tag that said, "Sammy's my hero." The second thing it would do is it would make them request you as a friend, and then the third thing it did is it took all of this and injected it in your page as well. So then whenever anyone visited your page, the same thing would happen. And within the span of about 20 hours, he had 1 million friends. He shut down MySpace for a couple hours, and at first we thought he didn't get in trouble, but actually January of this year he pleaded guilty to some stuff, and he's still kind of in trouble. But the interesting thing is it's a fun story to read because he goes through his blog and details out exactly how he did this. I mean, I'm not a hacker. Maybe some of you guys are. And when you start reading of how he got around all the filtering and the encoding, you really can understand exactly what you're up against when you're trying to filter this stuff. So, okay, the next one, pretty close to the same, but this one's called persistent or stored. And This one basically, instead of the one time where it's going to go back and be reflected to you, I want to store my script in a database so I can share it with all of you guys. A good example of this is, way back when, and actually new ones, guest book or a forum is a good one as well. Basically, if I have a guest book that's susceptible to this, that's not stripping out the tags, that's just letting me put whatever in the database, I can type my name in the name box. In the greeting box, I type in a script. What happens then is someone else, when they come back to the site, they view the guest book, guess what? They're going to get my script. So I actually inject it once, and everyone that views that page is going to get that. So
that one is also particularly dangerous, looking at your graphic there. In this case, the victim, that script that runs the script logged in the context of the victim. So if that victim in this case is a customer service rep, for example, that has the rights to open an account, transfer money, close accounts, the hacker now, their script will run in that security context with all their credentials, and they can do malicious things. They could close the accounts. So,
yeah. How do you protect against that? Pretty much the same way. Input validation, everything we talked about. It's, again, going to the server. So, again, all input's evil. Make sure that anything that's going to your server, you check what's coming in, and make sure you cleanse it before it comes in. Same exact stuff. Anything extra protection you can think on this type? Or
I think what you're talking about with the when you're encoding it for intent, that's a big deal. If it's a banking application where it's simple text,
right,
you don't want to be allowing anything that's not appropriate text. So
yeah, if you have a website that needs to put HTML back to the client, you got your work cut out for you. So forums and stuff like that, where they let you format stuff in HTML, you got a much harder job on your hands because you have to be a little more diligent about what you're sending back. Like you said, if it's just simple text coming back, it's a little bit easier on you as a developer to basically strip out everything, whitelisting like what we were talking about. So.
One of the interesting things is where does we keep talking about like user-generated content that gets input. What a lot of people don't understand is the breadth of the nature of what untrusted content is. It's more than just content the user could type in. It's the location. It's the URL and the address bar. The user doesn't have to type it. If you saw in the first example, someone could create a URL, append parameters that might find a vulnerability in your site, and actually, even though it said you had to click on it, you could get those navigations occur transparently. So the document location is untrusted. Any user input that comes from a form is untrusted. Any parameter over a query string, even if it's not one that originates off of a user form, is untrusted. My favorite one is the document referrer field is untrusted. And I'll just use this one as an example because this one usually blows people's minds. A lot of people have pages out there with these tracking GIFs. To try to, you put these GIFs on your page that kind of just call a little image on your server to track where they came from. It's a neat little, it's not really a web bug, it's just so you could do analysis. Oh, it's the most popular origination of people coming to my site coming from here. Well, a lot of those sites do it by just taking the referrer field on the client via script, appending it onto an image tag. Well, you might discover that, well, if that referrer can be manipulated in an interesting way, someone might find a way to close the quote, to open a script tag, and so on. Cookies can be untrusted. A simple reason, even though cookies run in your sandbox, if there's an XSX exploit on your site, now your cookie could become compromised. So literally every piece of information that originates from the client, you have to treat as untrusted. Then you have to figure out how to parse it or validate it or interrogate that value before you ever again return it to the client. So you basically have to validate it on input and then encode it on output. It's kind of the way I look at it. Every value that you send to the client should probably go through some encoder, even if the encoder does nothing more than just say output as is. So it forces you to express your intent before it gets back. Never reflect content directly from the client that comes to the server back to the client. If you do that, I guarantee someone will find a way to exploit it.
The last one, you don't actually hear talked about too much. I don't think it's as prevalent. I don't know if you guys know any statistics on this, but it's DOM-based local. Basically, it's the same type of exploit with something added to it. You're still going to use a URL that they need to click on, or like you said, not click on, that will actually work with the DOM. So let me actually go to this script. So You can see down on the bottom there, I have, again, a site that's looking for a query string. And instead of having the query string be the question mark, I have a pound sign. A lot of you may have sites that, whether you're going to use the document object model to do this or not, where you want to find out who the person is and you want to welcome them back. So you can utilize this to say, hey, welcome back, here you go. And if you're using the document object model to do that, what this is going to do when you put the pound sign in there instead of the question mark is the DOM is still going to be able to read that the name variable, but now what's happening is it's not going back to the server. So what this means is all that input validation that you did and all the black listing, white listing stuff you did on the server is circumvented. To protect against this, basically you want to do some JavaScript hardening. So you want to analyze everything that you're doing with the DOM on your web page and make sure that, again, all the input that's coming in strictly in the DOM is done there. One of the questions before we move on I actually had for you guys is, for the developers out there, do you guys in your company have someone that does security and handles security for you guys, either internal or external website stuff? You have one person. Do they do penetration? Actually, let's switch that around. Who doesn't? And do you guys have outward-facing websites? Okay.
Do you mean based on like security models for, saying, like our servers, or security models for taking a look at our code that gets published out to make sure?
No, the servers is a totally different talk. We're not talking firewalls. We're not talking any of that. We're talking strictly code. So for those that raised their hand, said they didn't have anyone, did you guys know what XSS was before? And are you doing stuff to fix that? So I saw someone smirk back there. I assume that's a no. You don't know how many companies that I go in. We're not a security testing firm. We're a development firm, and we go into companies and all over the place. The developers, like I said at the beginning, don't even have the first thought of security because their boss right next to them is saying, I need that page, I need it up on the site now, go. So they don't even do it. They don't even have time to think about it. So I think you as developers need to bring this up to your bosses, bring it up to whoever you're working with, and let them know how important it is. We're going to probably talk a little bit later about some exploits that have really hurt companies, but I think it should start with the developers, and you should kind of meld it into to how you develop. So.
Okay. Before I go on, is there any questions about XSS? Yes.
Shouldn't it be part of IIS or something to block XSS from happening?
The question was, shouldn't it be part of IIS to lock it out? I'll partially address that one. The problem comes, yes, there are libraries that help you. You saw that there was a reference to the anti-access library. It's hard to lock it out because you need to know the intent of what the value is being used for. You can't just magically shut off input and validate it because you have to know what you're validating it for. For example, I'll just pick up one of our properties, nothing to do with the security hole, but Spaces in Hotmail, I had to type rich HTML. Well, the server needs to know, well, we want to support HTML, and these are the HTML tags we want. So really what it comes down to is having the access to the tools and the libraries that will help you to proactively mitigate against and protect against this. And for that, I would go get those libraries, and from my perspective, as a web developer, yeah, I would argue that all web services should have those libraries built in, but they wouldn't work automatically. You need to be, as a developer, diligent and understand, here's the untrusted value, here's where I'm putting it in my database. Another interesting challenge is when you start following program flows, is you might validate information on input, and it might be totally fine, and you may have coerced it properly. There might not be any security issue in the input as far as you could tell. But your security hole may arise because you outputted it wrong into the wrong context. And that's why it can't be solved magically. You really have to follow your program flow. From the moment it comes in, validate it. When it goes out, encode it. And that's kind of the argument I always give people. Validate on incoming and encode on outgoing. We may, in some places, we go so far to validate on input and output just to be a little paranoid. We still validate, even though we know it should have been validated beforehand.
Yeah, and if you, for example, if you're a .NET developer, the default is if you're using the intrinsic controls, it does a lot of this for you. It's an intrinsic control. It's really hard to exploit it across-site scripting. Where you run into problems is when somebody does a response.write, they're creating custom responses, they're doing, if you're kind of following the normal, boring, if you will, web page with some text boxes, if you go the default, you're probably pretty safe because the .NET framework is going to do encoding for you. Where you almost always see the problem is when somebody does a response.write. And if Microsoft in a response said, anytime you do a response.write, we're going to strip all the HTML. Well, the reason you did the response.write is probably because you had some rich content you wanted to put back. So it would kind of kill the whole feature set. So it'd sort of be throwing out the baby with the bathwater, the old saying. I think it's very challenging. I think Microsoft's done a good job with the default stuff that comes with .NET, with the libraries that they've put out. But ultimately, it's the developer that makes the mistake. Microsoft can only, or any vendor, pick your vendor, can only do so much to protect the developer. And ultimately, as a developer, you write programs and make a mistake and you can shoot yourself in the foot. And it's the same problem we've had for years. Malloc, and if you were a C++ developer and you use malloc incorrectly, or you had buffer overflows.
The most important thing is to understand the technology. I mean, all this is education.
Yeah.
Understanding the technology and how to apply it. And then if you do make a mistake, how to mitigate, which is a topic we'll talk later when we ask that question about how many people have security plans. How do you mitigate against this? And so on. Is there any other question on XSS? We can also ask more later, too. Yes?
Are there any good built-in ways in .NET to encode checks you're injecting into a JavaScript section? Because HTML encode doesn't help you there.
Injecting into the middle of a chunk of JavaScript, just from a security perspective, is really, really dangerous. Like, wow, dangerous. The problem is you're already inside the script block, and chances are you're rendering JavaScript back. So then you have the task of figuring out what's bad JavaScript, which is incredibly challenging.
Well,
You're just putting your
actually, what's your question about? No, you're just a variable, injecting some content into a variable.
Okay.
Yeah, I can't speak to what's built in. I know we have a modified version of encode that we use in Windows Live to make sure we cover the escape. Basically, if you think of it this way, you encode. Don't implement this as simple as I'm going to explain it, because I'm just going to give this simple. We also make sure we encode out the quote, single quote, double quote, line breaks, in addition to the full escaping. I mean, there's a few more checks there because you have to deal with DBC. I mean, it's a little more complicated, but we do use a custom one. I do not know what's actually built in.
You'd probably also want to make sure you're whitelisting. So, you would allow, for example, characters A to Z, 0 to 9. Pick anything else, kick it. And you'd want to try to keep that list as contained as you possibly could.
What's interesting on that question, and I'll jump a little ahead because I still believe it falls under XSS, is how many people have heard the term JSON? JSON. All right. How many people use eval in your JavaScript? All right. Do you use eval yourself, or is it coming from some library?
We use it ourselves.
All right. You should replace the letter A in eval with I. Evil. Eval is... I like to just make a general statement that never use eval in your code. Remove it. Eliminate it. If you're evaling something, you're probably dealing with late-bound generated content on the client, because there's no other reason to eval something. And if that's the case, you're probably evaling something untrusted, which basically means you're walking yourself into a double whammy. The one place eval, I would argue, is permitted, and there's a great library written by a guy named Douglas Crawford at Yahoo. And if you've heard of JSON, you've probably heard of www.json.org, JSON.org. He has two ways of dealing with JSON expressions. One, you parse them manually. I don't prefer that approach merely for perf. It's expensive to do the parsing. But he has this wonderful regular expression that will make sure that your JSON cannot contain arbitrarily executed code. So you could give it a JSON string and eval, and it'll only eval literal objects, strings, objects, numbers, not objects, strings, numbers, and so on, but it will not allow you to execute arbitrary functions or so on. That is the one instance. What was that?
That's how ASP.NET library implements JSON on the client side. When it gets JSON string back to the client, it will just call eval.
And if you're going to call eval, I would call the safe eval that you could get from the JSON.org library. This is just you have to be very careful. If you know what you're doing, it's another story. The reason why I said that is outside of dealing with JSON strings, which should be literal objects that aren't executing code, almost any other use of eval can be written without it. Someone could convince me wrong, but I've never had someone show me a piece of code outside of a literal string that I could put through a safe JSON evaluation that needed eval. And eval is usually the root of many, many, many problems, mostly because it's a crux. People look at that and say, here's a string, just execute the thing, throw it in eval, and I'm happy, and off I go. And that's usually the first place any hacker's going to go look for your XSS exploit. And again, it's one of those things that JSON has basically become a foundation, a fundamental part of, quote, AJAX per se. But JSON has been around since the beginning of JavaScript. It's just a serialized notation of a JavaScript object. It's the way JavaScript worked since Brendan, who's now works in Mozilla, but Brendan Knight, the architect who invented JavaScript, that was JSON from day one back in like '93. So it just got another one of those things that got a fancy acronym. But I would be very careful with your use of JSON. That's just one of those places where I kind of cringe when I see it in code. What was that? I'm sorry, eval, yes. Thank you for correcting me. Eval. JSON's fine if you run it through the safe eval. And just to put it more bluntly, we use the same JSON regular expression that Douglas wrote on his JSON.org site. So that regular expression up there has been vetted out by Yahoo, by Mike and Microsoft. Not only for security, but for performance. So it's probably about as efficient as you're going to get for dealing with JSON. And if there's ever an issue, I'm confident, Douglas at this conference, I'm sure you'd agree, I think you may actually be here, that if there's ever an issue with that, it will get fixed and it'll get quickly and disseminated and communicated. But no one has broken that expression yet as far as I know. Any other XSS questions? How many people have heard of XSRF? Another fun acronym. All right, we got one hand. This one is actually, in my mind, a very, almost in some ways could be more scary than XSS because it's very misunderstood. It's not, actually see one person raise his hand. And the potential for abuse with it is extremely high if you don't mitigate against it. And with that, I'll hand it over for another quick presentation.
I'm just going to walk through a couple of slides real quick and just sort of walk through. Where am I at? There I am. Okay. And I wasn't going to use our thing, but I needed a white background for my demo. So cross-site request forgery or one-click attacks. The concept behind these attacks is really simple. The theory is I'm on website A. Actually, let me walk you through it. It helps out a bit to kind of see the exploitation. I'm a user, and I go to a website, and we'll call it website A. And the good guy side is the normal website, and the bad guy side has the black hat. So big on icons here. So I'm a user, and I go to a website. And when I go to the website, what happens is I log in, and it gives me a session token. I become authenticated, and that's done through cookies, and this is just standard web stuff. I go to the website, I log in, I get a session token that's now in my browser. It's built into my browser. Was that a? Ooh, handy. So did I get this rascal to work here? Glad I didn't miss there to blind myself. So I'm a user here. I go log into the website. That gives me back a session token. And honestly, this wouldn't matter if it was a .NET site, Java site. Pick your favorite website. You're going to use session tokens the same way. It's just a cookie. At some later point in time, that user now browses over to website B. And website B has a link in it that's malicious. And the goal of it is that website B is going to try to make you do something on website A that you didn't intend on doing. So website B forces you to send a request off to website A that asks to do something malicious. And the nature of the browser is that when the request is sent from your browser off to website A, it's going to send it with all your session tokens and all your cookies. So if you were logged in as an administrator and you can reboot the server, it can reboot the server. Or whatever it is you can do. If you can transfer money, it can transfer money. Let me walk you through a very specific example. I'll show you the source code example of this. And it's one of those things when you see it, you kind of go, oh, that's simple. And it really is a painfully simple attack, and the defense is actually pretty simple, but it's amazingly common how often this issue shows up. So here's an example. I go off to my website, and I log in. So I log in. When I do that login, again, the website sends me back a session token that's stored in my cookies on my browser. So I've got my nice little session token there. Now I'm going to navigate away from that website off to the malicious website. And you could ask, how would that happen? It could happen pretty easily. If you're a user of a system and there's a website, there's a forum, for example, groups of people tend to navigate to the same sets of sites. So you may have a banker website, but then this other website may just be a discussion forum bulletin board that I go hack. It could be a lot of different things. So I go off to this website, and I want to show you how this hack can actually occur without you clicking anything. You just went to the malicious website, or the website that had the malicious link. This site, I actually set this up in a .NET app just to kind of test it out. And notice it says, hello, this is a very bad place. Bad things can happen without you even knowing it. That's all I did as a user. But notice down here on the bottom, that little image sitting right there, that the image didn't load. If we look at the image code, the actual image tag itself, right here, notice it's an image tag. It's setting the source off to this spyware.com, and that's the good guy website, although the name is a bit strange. So that's the link off of this one, and it's go to spyware/admin, delete user.aspx, and then it passes in a parameter of the user that it wants to actually delete. What the browser does is it's perfectly legal for one website to have an image link that links off to another site. That's a perfectly valid thing to have happen. What happens, though, is my browser sends the request off to the good guy website, but when it does it, notice that it sends a link. The image request gets transferred into just a straight HTTP request, but the browser does exactly what browsers are supposed to do. It grabs all the cookies that were meant to go to this main website, attaches them to that request, and sends them along with it. So that image tag just sent off a request to go delete a user, and it happens authenticated as the person that was logged in. So I'm logged into website A, I go to the bad guy website, it then, just through an image tag, forces me to go delete something or do some action that I didn't intend. Now, the image tag is the simplest one using URLs. There's ways to get it to be a post. There's ways to do a lot of other things, though. But that's the basics of it. It's getting somebody to do something on a different website. So that's the basis of cross-site request forgery. And notice in this case, it actually deleted that user. And this is all, I developed this app, and all I did was, took a request.email address and did a delete from a database based on whatever that was. So ways to avoid this, it's actually a fairly avoidable thing. What you want to do is know that the request that comes to your page, so you've got an ASPX page or a page that you're created, you want to make sure that you're really comfortable that the request that just got to your web page actually was generated by somebody being on your web page. So it wasn't in response to some other form being posted in. That it was actually a page that you rendered and the user interacted with it. The most common way of doing that, and probably one of the simplest ways to do this, is we can put a hidden parameter on the form. So in this case, let's say we've got a web form that deletes a user. We would put a hidden parameter on there that would be some kind of value that you generate on the fly. It would be a cryptographically random token. I've called it a page hash. You could create a cryptographically random string, stick it in a hidden parameter. The big thing is you don't want anybody to be able to predict it. You don't want predictability in that token. So every time you render that page, you create a new token. It's not a static thing. It's something you render every time you draw that screen. Then you remember it. So you remember it in a session variable. Whenever somebody posts that page back in, you simply make sure, are they giving me the right token? If they are, you can feel pretty comfortable that it came from that site.
Is this what is sometimes referred to as a canary?
Yes.
Yes.
Yes. So, but it's the same concept. The concept is make sure that you know that it came from your page. And then now the developer, where you'll find problems, and one of the reasons this is so commonly misdone, is historically developers have had this habit of it. Let's say I write a page that updates a user object in some way. So it takes a bunch of parameters and then updates a database with that. Well, they decide that they like that code, so they'll have 20 different pages on that website submit into this one utility page to do something. In that case, they kind of have to break that model because now it's one form gets validated, one request gets validated for that one action. So that's kind of the pattern. You see that with email us pages. For example, there'll be a contact us form, and or it's something that sends an email. You've got to make sure that that was actually the page that you rendered, and then you respond to that rendered page. So, any questions about cross-site request forgery? Sort of how it.
One of the big things about cross-site request forgery is I kind of use it. It's the same idea. I had a general rule for XSS. Any create, update, or delete operation should probably be protected against cross-site request forgery. So if you're creating information, updating, or deleting, you want to protect against it. A similar one, which I like to mention, I haven't seen this much recently, but in the early days of the web, I used to see this all the time. Be very careful putting your authentication tokens into query strings onto the URL. My favorite one, and I remember this from years ago, and I haven't really looked at my logs on my public site, but every once in a while I used to see these refer fields. I love refer as an exploit, but these refer fields coming from other sites that would contain the authentication token of the user, because you go to some blog and they click on a hyperlink to my site, but in the URL it had all the authentication information of the user and it got carried to my site. I can now use that in theory to replay a cross-domain request forgery attack if that cookie was within the right time window, that token was within the time window. So you also not only have to make sure these are cryptographically secure, but you protect them. You treat them like very important data that cannot leave the context of your domain. If there's any way those could leave your site, you might open yourself up for a small window of time.
I think a place where this also applies pretty heavily is, with AJAX and Atlas-based applications, it's the nature of how you write a lot of these applications. You'll create a utility page, so you've got the website that renders lots of screens and does the graphical part of it. But then you can have utility pages that you're calling from JavaScript that perform actions. So web services, you've got a web service. The question becomes now you've got to make sure that that web service is only responding to requests from the website itself. You don't want to just have some web service hanging out there that just accepts requests from anywhere and performs whatever action you tell it to. So you've got to look at how do you know that the request that hits that web service is actually coming from that AJAX or a website that you've drawn. You've got to be very conscious of that, of where does the request come from? How do I know it comes from my page, be it a web form or AJAX-based or JavaScript-based?
And another way, since you brought up the term canary, the way one of the ways we use canaries a lot is we will put a cryptographically secure, non-replayable value with a short time window into the cookie, into the session cookie. We will take that session cookie and then put it into the post that goes back with the post. So then all you need to do on the back end is compare the session cookie to the value coming back. If they're equal, you know it's a legitimate call. If they're not equal, you know it's not. The key thing here is that cookie has to not be replayable, has to have a short time window, and so on. Another trick, which isn't a very secure token, but it does work well with XML-HP requests, which is a common foundation for all your AJAX, is inject a custom header value into all your HTTP posts, XML-HP posts or gets. Put a custom header in there. The interesting thing about that one is based on the browser default settings, that header doesn't even have to be a unique value. No other page, due to the domain policy, should be able to inject a header value. So you can get a reasonable level of protection by merely just putting a custom header on your XML request with a static value. That's not as good as a randomly cryptographically secure number, but it's a hell of a lot better than than most sites currently have, which is nothing. I did see a hand go up when we were jumping in. Was there a question?
So actually, the question I have is with this new AJAX-based applications. So is it true that if we don't use word string as a way of recording actions, like the old form-based application where it's actually post delete, actually post update, or update delete, instead we use XML-HTTP to post data back to the server and use web service to handle the request? Will this kind of problem be resolved?
The question was, if you use XML post, will this problem be resolved? It would only be resolved if you went to that one extra step, like I just said, and probably put the extra static header in there, the custom header value. The reason is your server's not going to distinguish between an XML post with post values and someone simulating the same thing with an HTML form and posting it to the same URL.
That's in my example, we actually, this is one for cross-site script. I used to love to use this as my demo. I would simply create a form on my hacker website, if you will. I would create an HTML form that had a bunch of hidden parameters that had my malicious content, and on the body load of that HTML page, it would call a form.post, and that posted off to the real website.
You can hack by simulating a web service call back to it.
Yes.
Yeah, and if you look at a .NET, look at the WSDL, go to the web service, the WSDL for a .NET. It gives you like 5 different ways, and one of the simplest ways is just a post.
The interesting thing about XSRF is that it's a post and forget operation. The page that's making that attack will not get a result back that they can interpret because of the cross-domain boundaries. So it's basically calling a transaction on your server, an atomic operation. So when it hits your server, If there was a way I can encapsulate in one call, transfer money from account A to account B, I don't even care if I hear back from that server. Then if I could get that call off and your server responds, I won. I don't even care about the return result. I don't care about processing information. All I care about is acting on your behalf in a transaction, just causing the transaction to occur. Because that's the other key thing that a lot of times I see this conversation start and people go, oh my God, wait, isn't the browser sandbox supposed to protect against this? The browser sandbox is actually working just the way it should be. I cannot interact with the content. I can't interact with the results. But what I can do is just basically what this is a URL navigation. I'm just navigating to something that just happens to be doing a create, update, or delete operation. And that's why, again, as I say, just like XSS is about validate and encode, this is about any transaction that occurs on your system should be protected that originates from the client. It's a similar philosophy. Yes?
When you were talking about defending against having like an AJAX utility page and having a custom header, one thing I thought of was if you encapsulated your AJAX calls with that custom header into a JavaScript include, and the attacker could cross-domain include that JS on your site and then call your methods, would that be a way of getting around that?
The question was about using JavaScript. If I understood your question, it's about using JavaScript for your web service call, so you're using a JS file as the return?
Right, like you have a external JavaScript file on your site that's a good site that encapsulates sending AJAX calls off with a custom HTTP header value that will authenticate it.
Okay.
And then the malicious site does a cross-domain JavaScript include to that JavaScript file and gains access to your methods.
I understand your question.
Would that get broken by the cross-domain?
Unfortunately, it doesn't work. And I'll explain. The question was, can you use a custom header on a JavaScript file? And the problem is you can't put custom headers on your JavaScript requests. They're simple gets. All you can do, the only way you can do that is via an XML post. A header, you cannot set custom headers. When you put script source equals, you can set query string values. That's not the header.
Right.
So if you put the... There's no way to get the header on the outgoing request with the JavaScript file with the JavaScript request. It wouldn't set it. We could discuss that one offline unless other people need this to be followed through. What you can do though is, in general, here's another one of my rules that I try to avoid, just like eval. I try to avoid using JavaScript to return user information. Returning user information, personal information in JavaScript is extremely hard to protect against. You will have seen exploits, and I'm not going to point fingers, but basically on every major site, we've all tried it. We've all put a JavaScript include that returns whether the Hotmail, mail information, some other information. Almost every site that has tried this has been burned to return personal information via JavaScript without a real amount of protection. And the protection usually has to fall back to using a canary again, where when you request a script, you need to have this cryptographically unique value put at the end of the query string, and then you have to validate it. And the other interesting point about that one, and I'll bring this one up, is another source of a lot of, and these are more, it's in between XSS and XSRF, is MIME typing. If you're returning JavaScript to the client, make sure your MIME type is text/JavaScript. If you're returning HTML, make sure it's text HTML. And I'm just going to give the example. Imagine you're returning a dynamic JavaScript with user information. And it's dynamic. So somehow in the query string to that JavaScript, you provided a value. You did not validate that value properly, so maybe you have an XSS exploit. Well, if the MIME type was JavaScript, it wouldn't really be easily, no one would be able to break it, because if they loaded that code in their site, they wouldn't be executing the context of your domain. But if that JavaScript could be run as HTML, I could load that page. It might look like a bunch of randomly gobbledygook because it's the code, but at some point I could hit some untrusted value that could start executing my code. It's kind of hard to explain that without a whiteboard, but the key point here is if you're serving JavaScript, make sure your MIME type is JavaScript. If you're serving XML, make sure your MIME type is XML. But you have to be careful with that one because of XSL, and that's getting beyond, I think, the scope of what we could discuss in the panel. And if you're dealing with HTML, make sure the MIME type is HTML. Again, none of this is new to the world of security or the world of the web. It's just that with the advent of Web 2.0, we've basically we just extended the breadth and the basically the surface of which people can enter into our applications. Any other questions on XSRF? Yes?
Is the ASP.0 secure?
Is the question?
Yeah, to be kind of expert.
Is it? I believe it is. I'd have to look if they actually automatically do canaries. We don't use all these AJAX libraries on Windows Live. Maybe you know.
There's an option, and I'd have to go look it up. There's an option that you can put on a page when you do a page validation that will stick a canary. I think it. I have to look at it. It's either in the. It's one of the hidden parameters that goes along. I forgot the name, but I apologize. But there's one of them that basically where the page has to be. The page will only be accepted, and part of the validation is to say, was this page posted from me, and it effectively sticks a canary in there.
I know what you mean.
Yeah.
It actually does two things to try and protect it against it. One, it's by default you can only do a post, and it also does a custom inject something into the header, a custom header. But just like the let me ask you this: so the developers, how many of you did 1.0.net? And then when you went to 1.1, did you have your sites break? And did you go into the web config and turn off validate request? Bad. That's exactly there to stop cross-site request scripting. So they'll do stuff like that to try and help you out, but you got to kind of take a little step beyond that. If you want a good example of exactly how it's done, Scott Guthrie on his blog gives you an example of how it tries to do that.
With securing web applications in particular, your threat, coming from the pointy hair boss perspective here, is you're defending if you're dealing with any kind of credit card information or any kind of PII data. Your threat is fraud from the Eastern European bloc, from Chinese hackers, et cetera. So you want to make sure that you're not just looking for one point solution to solve all things web security related. It's called defense in depth, and it's not a product, it's not a tool, it's a process, people, etc. within your organization, learning how to write secure code, doing cross-checks via XP programming style if you like. And there's a great book by Michael Howard and Steve Lipner called Writing Secure Code. I recommend all you guys picking up because it is a large process to get it right.
I think.
Michael Howard. He's anyways.
Yeah, there's also there's a credit card, very credit card specific, but it's a good sort of mini how-to called the PCI policy. If you do credit cards, you're subject to it, whether or not you know it. But it's really an audit. It tells the audit steps that somebody has to go through before they're approved for credit cards. And it's a good general guideline of the kind of questions you want to be asking. And it goes through cross-site scripting, cross-site request forgery, and it's not the end-all be-all by any means, but it's a good kind of a guideline that talks about, are you encrypting your credit cards? Are you doing steps A, B, and C? And it's a good picture of what a secure process looks like. Good start anyway.
Yeah, I actually like to hit almost the complete opposite side of this. You'll hear a lot in talks where they'll talk about banks and PCI and all that stuff, and I'll go to companies, and even if it's an internal intranet site or it's a website, and they'll have users and passwords in there that aren't encrypted, and they'll say to me, well, there's not really anything up on the website. It's not really that big of a problem. We're not really protecting anything. And then it's usually a group of about 10 people, and I'll ask them, okay, how many people use the same password for their AOL account, for their MSN account, for their bank account, for everything? So even if you're not a big bank, you're not whatever, you have to protect that stuff. Obviously, if they're keeping it under the keyboard, you can't do that. But all data needs to be protected because you don't know how someone's going to use it.
Or how to use your server. There was a FBI sting a while ago where they apprehended an 80-year-old grandma because she had allegedly broken into a bank, and they were pretty darn well convinced that she was the person, but in fact her machine had been taken over by some folks, and I know the guy who did the forensics on the box. So you don't want to be that server admin that had the fraud perpetuate from your box because of bad programming practices and be talking with the FBI. It does happen.
Switching gears a little, one of the big changes with the Web 2.0 landscape is this concept of mashups. Again, this is not a new technology, it's just applying how we use things. And mashups, I believe, actually bring some very interesting security concerns into the mix that are often overlooked. And I'll just open up to the panel, since I haven't been a great moderator, and let them speak continually here.
The biggest thing I think with when you're taking content from someone else's website and sticking it on yours, is now you have to consider that you're subject to their ability to secure that data. So if you're taking a bunch of HTML off somebody else's website and showing it on your website, and they have cross-site scripting, well, Merry Christmas, now you have cross-site scripting. So it becomes a trust thing, and we talked about, there's some companies that you can probably trust at a reasonable level. If you were using, some of the Microsoft mapping system or a Google Maps or, some of the other, the big players in the industry, you can probably feel pretty safe that those guys have got their stuff together. But if you're taking data feeds off of, Charlie's website and sticking it on yours, well, now, how good is Charlie? How good is this other person at securing their data? And anytime you put somebody else's content in your website, you now inherit all of their security goodness, or ultimately their badness, their mistakes, you inherit those. And now your liability is people trust you, but you've now trusted somebody else, so that it becomes a huge trust issue. How much do you trust that person that you're getting the data from?
To be really explicit, when you mash up someone else's script, when you go script source equals pointing to someone else's server other than your own, you are running their code in the context of your domain, your authenticated user, and so on. And more so, you can't even look at that script and say, oh, it looks good, I now trust it, because since that script is coming from another server, how do you know? 1 out of every 1,000 requests, they serve a malicious one. In other words, so you really need to make sure you have a certain level of trust and agreement that the person you're partnering with should hopefully have an equally or more rigid security policy than you have. Now, the scary thing is when we ask that question, no one raised their hand, so the odds are most of them are equal. But the thing is that, again, it comes down to the users trusting you to protect their data. When you partner with someone else, you're trusting that that partner is going to be equally secure and equally protective. I sit at Microsoft. Our security policies, I'm hoping, are at the top of the industry. And we do our best to make sure it's secure, and we have to because we have a lot of users, and we're actually under federal scrutiny and so on. So yes, we're doing it. But when you go out and go pick up that little search widget, which is a script source equals from Joe's Hobbyist in his garage, you really better feel comfortable that he's going to do that. Is there an agreement there? What's the SLAs and so on? And at this point, the way the browsers work, there's really not much you could do to mitigate this other than have implied trust. You want to put those ads from that partner. You want to put the mapping from that partner. There's no way around it. That code is going to have to run in the context of your domain. That's just the way the browser works today.
I think a point that Scott's touching on is really about brand equity, brand value, and consumer confidence. So if you're like eBay.com and a user gets frauded, even though it's coming from a third-party seller that you've never met in your entire life, it's eBay's brand at stake, and that gets back to supporting and securing your consumers. So that's my comment there.
Yeah, it's things you don't even think about. RSS feeds, ads that you're putting on your site. I was just reading recently of this guy who, wasn't on your site, but it's the same type of thing. They were pulling a feed on new articles that were coming up, and he was able to inject in the title of the article some script. So everyone 7,000 people that were browsing that page, that little ticker on the side, infected all 7,000 people that were running it. It's, you got to, again, remember where the stuff's coming from, and if you didn't do it, you have to make sure you have trust between those boundaries. So
that's actually a great point. With all these new web services, a lot of us are starting to build what I call web proxies, where you're basically building bridges between your service and another service. You need to be, just like content coming from the client's untrusted, if you're loading any content from an arbitrary web service into the context of your page, that has to be treated untrusted too. And if it's being loaded directly in your page, as in the case of that RSS reader, you better really trust that they're doing it right because you can't stop it. It's up to the partner to stop it. So there's a lot of interesting challenges. Is there any questions about mashups or security in that context? It's one of those areas that doesn't really get much attention.
I can add another thing too. We're hired oftentimes to come in and verify the security of the third party. So if you are doing a mashup with, say, Google or whatever, and you have an enterprise app, you can have the conversation with them. You can ask them for the last security audit. You can have a service level agreement that you could draft and partner in with them, so you have some form of legal protection if something bad does happen with your merged technologies. You have a fail safe.
So general high-level question, how many people believe that after all this that we could build a perfectly secure app on the web? I didn't expect any hands. So it really leads to the next thing, which is since we have experts from testing and development and so on, how would we mitigate, since security holes are inevitable, what's the approaches we should take to mitigate or protect, or how should we think about this?
I think the developer has to, it's all about knowing what's out there. I mean, like I said, from my perspective, developers don't even think about it at all. And they don't even want to bring it up to their boss. The boss has deadlines. So on both sides, we have more developers in here than bosses, but the boss has to realize if they don't take care of it now, it's going to hurt them and their company in the future. And the developer has to understand that if they don't mention it to their boss, the boss is going to say, why didn't you tell me about this? I know you went to MIX. You sat in on that security talk. You should know about this stuff. And it's just, you don't have to do training, so intense that you know everything about cross-site scripting, that you know everything about security. There's companies that do that. But if you can, keep track of new things that are coming up and try and stay on top of it and mix that into your development, it's going to make a world of difference. Because like we said at the beginning, cross-site scripting has been around forever. You'd think it'd be taken care of by now. But the fact that people just ignore it, makes it easy for hackers to take advantage of it.
I'll use myself as an example of what not to do. The reason I came to work for the company I'm with now, SPY, I was working at a bank as an architect, and we did exactly the wrong thing. We developed an application. We were getting ready to go live, and the guys that had just founded SPY, the penetration testers, came in and tested it. And literally in a period of 2 days, they were able to get every name, address, social security number, everything out of the system. So they brought in this big, literally it was a stack of paper this big, and said, here, we were able to do this. Well, we had the wrong response. And the wrong response was everybody freaked, started pointing fingers, who was trying to figure out whose fault it was. That was the wrong response. And what we should have done, and looking back, I think what companies do is, first off, realize you're going to have defects. You're going to have holes. And it may be honestly something that right now, you don't know, nobody knows exists. 3 months, 6 months, 12 months from now, there could be some totally new technique. Cross-site request forgery is a great example. It's always been there. People got good at it. So, you may be writing code today that's fundamentally vulnerable, and I may be doing the same thing, but we just don't know it yet because nobody's figured out how to hack it yet. So, 6 months, 9 months from now, somebody finds some new technique, your existing applications have holes. The biggest thing is understand how do we react. So, first thing is, how dangerous is it? So, what's the probability that somebody can hack me? Do you have to be logged in? How many people can log in? What are the mitigating factors? So, how many people could actually exploit this? Next is, if they exploited me, how dangerous is it? So what's the impact to my business? Do I go bankrupt, or is it a little embarrassing? And what's the probability of it? Once you know those things, and you want to figure those things out very, very quick, it's sort of triage. Like I was a medic in the Army, we always did triage. How bad is it, and what's the chance of this guy getting hurt? Once you do that, then you can take a conscious reaction, and those reactions can go from the extreme of pull the plug on the server, turn it off, and then go fix the code, down to a conscious plan that says, okay, we're going to go fix the code, we're going to test it, we're going to release the fix. But you want to have a plan of how do we actually quantify the problem, and then how do we address it in a rational way. Don't do what we did at the bank when I was at. Everybody starts pointing fingers, and that's not good. So it's really about the process, understanding we're going to have issues, how do we react? And then reacting that way, so have a plan. And it's more of a process of how do we deal with this? And that's one of Microsoft, I think, historically going back, Microsoft and a lot of vendors back, if you go back to the early 2000s, they used to get a lot of dings where somebody would report a defect to them and they would react slowly or too fast. And one of the things they've gotten good at, and other vendors have gotten good at this as well, is when somebody reports defects, they react appropriately now. And I think the industry's matured, Microsoft along with that industry. And I think as companies, we have to do the same thing, is learn to react maturely and consciously. So.
Absolutely, and we are the company that gets paid to break into banks, et cetera. And so I'll tell you, from our experience, the people that are harder to break into, they have that plan, and they've executed on the plan. The plan's been bought off by executive management. It's not a grassroots effort ever. You'll never get the budget and buy-in, the training, et cetera, to help get your team in place. the emergency response is key. You don't want to have a negative reaction to the vulnerability if they've logged it. You want to work with the researcher if they've contacted you about the vuln and remediate it effectively.
A quick question: how many people here are enablers that are trying to expose web services and so on for partners? Okay, there's only one or two. The one other aspect is I kind of put this on slightly under security, but it's not really a security attack. But in the beginning I made the comment, one of the big changes in Web 2.0 was stuff that used to sit behind your firewall was now moved to the front. The other issue you run into is what I call the unintended consequences of doing that. Once you provide public APIs, things go beyond security. They become down to, well, you're providing an interface that you want people to experiment with. But if someone experiments with it, even if they didn't mean to do it maliciously, they can now become a security concern. And my favorite example is, because we see this in Microsoft all the time, but we know how to throttle for it, is the guy that wrote the code to go hit your service went away on vacation and didn't know he was an infinite loop on a 7 megabit connection pounding your service to death. Now, I see smirking, but that's not so much a security vulnerability where they can steal data, but it is an attack against your service. And it's one of those things you really have to plan for. The moment you put a service outside your firewall, regardless if you intend it to be consumed or not. And my favorite example of this, and I'm going to use it because it's not a Microsoft example, and I don't know if they intended it to do this, but I remember when Gmail came out with their great APIs that ran the Gmail engine, and they started talking about all the people that turned it into folder share. They started posting their files to it. I don't know if they intended to do it or not, but it was actually quite a genius scenario that people discovered. The point there was if they didn't intend to do it or not, it could become a potential security risk. Now they have scale that they need to consider that may have never been addressed in their initial projections. They may now have APIs that they expected to be called in the order of ABC being called in the order of CBA because people are experimenting. One of the beauties and perhaps the greatest downfalls, depending on your point of view, of this new Web 2.0 is the whole world of experimentation. People look at all these public scripts and public APIs as a big playground. And it's actually really cool because it creates some really interesting innovation, but it's also really scary if you're a vendor trying to provide anything, even if it's only for your own use. So one of the things you should always do is have a strategy in place. What are you going to do when that public API that you intended just for your AJAX apps, people start exploring? Now, if you're really good and you protect perfectly with XSRF and it cannot be used for cross-domain request forgery and so on, it's going to be very hard for people to exploit your apps short of building desktop applications, stuff outside the browser. But the interesting thing is people will build things outside the browser, so you still have to be ready for it. And I like to bring that one up because, again, it's one of those things that people don't think about. It's like, oh, this is a private API. Nope, once it's outside your firewall, you have to presume it's public. End of story, even if you don't document it. On that side, and the reason why I say that is JavaScript. Oh, I always understand this is slightly security, but everyone brings up JavaScript obfuscation. I'm going to obfuscate my JavaScript and no one will figure it out. No one's ever shown me a script file that within 20 minutes I can tell you exactly what it was doing. Now fine, I've been doing this 10 years, but hackers are even more creative than I am. It's not very hard. You have all the stuff in plain text. So don't think you're protecting yourself via obfuscating your code either. When I talk to people about code obfuscation, it's not about code obfuscation, it's called code compression. You're doing things to make your code smaller, not to protect it. You're trying to protect yourself with your trademarks and I hate to say it, with your lawyers and so on. You're not protecting code via trying to tweak your variables down to one character. So the other thing is not only your APIs, the moment they're outside your firewall, they're public. You have to assume all your code is public. So anything you do in your code can be reverse engineered in the client and investigated and used against you. So you got to be aware of that. Don't think that you could do some fancy escaping or manipulation on the client. In that same breath, if you're doing validation on the client, any validation on the client is an optimization step. If you're validating a phone number, the guy typed in 7 digits. Those 7 digits, if you validate it on the client, you still got to assume when it hits your server, it could be 20 digits. You always have to revalidate on the server. The client is merely an optimization path. You're just trying to save maybe that round trip because the guy's typing it. But the malicious guy is not going to go through your client code. He's going to hit your server directly with those 20 or the 2,000 characters causing the buffer overrun or whatever else. So you're really building a very interesting, your applications are a very interesting dynamic when you're building them on the web and so on.
You run into the same problem with attacks hear the term called a bridged attack. So the idea being, you develop web services. So the question was, how many people are developing these public web services? How many people are just developing web services? Just plain old webs. Most people are. .NET takes 30 seconds. We're seeing a new type of attack where somebody creates a web service for the internal system, internal application. So it's internal only. It processes a credit card or opens an account or does some internal low-level functionality. Well, then somebody that's internal only. So then somebody that's creating an external website wants to call that. So what they do is instead of actually writing code to do proper validation, they just put a web service on their page that's publicly accessible that just turns around and calls your internal code. Well, now there's access to from the outside world all the way in through that bridge. Well, all of a sudden now you've got this situation where a hacker figures that out and starts attacking you. Well, do you cut off that? Do you cut off the entire website, which is effectively the same as pulling the plug, or how do you throttle it? It kind of gets in the same questions of how do you throttle it, how do you pick which request do you handle? And you kind of have to think through it. Who are my users? How could they attack me? Internal becomes external very quickly in a Web 2.0 environment where we can just set up bridges. Give me 30 seconds, I'll create a bridge to a web service. It's trivial. So you've got to think through, even if you're creating those internal web services, what if somebody out there messes up? How can I mitigate that? And sometimes there may be nothing. You just have to think through it. How can I mitigate those challenges?
How many of you just develop intranets and don't think you have to worry? Yeah. There's a great website. I think it's called hackers.org.
Mm-hmm. There's a
guy named
hackers and a
R Snake.
slackers.
He's got a real name. His name's R Snake, and this is a recent post. And don't ask me exactly how. The whole site is basically about hacking. He exposes places to hack. And a recent post was talking about how to use cross-site request forgery and malware to infiltrate intranets and gain control of intranets. So you have to protect your stuff no matter where you're at. Obviously there's some other stuff, network security, that you have to get through, but he's got a great article on there about that. So.
On that site, there's a great thing. Just go to your favorite search engine, searchlive.com, which I know it is, and type in XSS cheat sheet, and it's on his site. And it's a great site if you want to see the creative ways that you can escape and encode values. It'll just give you a new perspective on the different ways that, and a myriad of ways that people could take an ordinary string and encode it in many, many different ways. That site also, not that I'm going to push around, since you already brought up hackers, and there's his corresponding site, slackers.org, which is a discussion group. But you could actually discover, if you want to use it as a learning experience, you can see exactly how a lot of these sites are getting hacked. Be careful looking at the site because they literally point out exploits across the whole web. But you could use it to learn more about XSS by seeing it in the real world, in the wild. It really is quite amazing how pervasive this issue is. And I think it was pretty clear from the response to this room, it's an issue that is not getting the respect it needs, or worst case, it's getting glorified in very negative ways when it shouldn't be. The key thing here, we have talked about mitigation. I kind of view this whole thing as a topic of education. Nothing we're discussing here is rocket science. It's just understanding the implications and the desire of what you're trying to achieve and just mitigating and protecting against it. The moment you understand this and you make your first mistake of encoding, since most of you are developers, I'll just assume you're the type A type personality developer that many of us are, you don't want to make that mistake again. It actually hurts your ego and insults you when you do things like that. So when you understand and you see it, and I'll admit, I made this mistake and I've been doing this 10 years. I've exposed holes and I fixed them. I never make that mistake again after I do it once. Once you learn and you see it, you won't do it again. One of my big objectives when I sit around at Microsoft is when I make a mistake, I don't bottle up and go fix it. I run around and broadcast, look at the mistake I made and look at how we fixed it. Don't you follow my footsteps. And everyone in the org is very receptive, and we learn, and we get better together. It's not something you do in isolation. It's something you do as your team, if you're developing in a team and so on. The XSRF, trying to solve that universally in your organization, whether turning on an ASP.NET flag or so on. Just being proactive about it. And then when it does happen, have the appropriate strategy, which is not the finger pointing, which is, okay, post-mortem it, learn from it, and move on. Now, if your site's endemic with thousands of holes, okay, you have another set of issues. But if they will pop up, just respond to them, improve, and go on. And make sure that if you've learned things here, that you share it with your peers and so on. And hopefully the state of the web improves and we stop seeing these glamorized articles that pop up talking about how the Web 2.0 is a big morass of insecurity, which I don't believe it is. It's just a matter of we're just not properly educating everyone about it. We have quite a bit of time here, so we could open up to just questions about anything we talked about, anything else about security, and so on.
I wanted to throw something in there
Oh,
real
yeah,
quick. For you guys looking to get some more education post this talk here, OWASP.org. If you're not familiar with it, it's OWASP.org. It's a great place to go visit and check out all the, the OWASP top 10. I'm sure you all heard about it. And then WASP too, Web Application Security Consortium.org is a good place to go.
Cool.
Yes?
I have a question about ASP.NET. The lot of data that you get from when you put on a web page, you put components, what are the data in Visual Studio, and they do like client-side validation. Do they do the server-side validation too? On both sides.
If you call,
If you put the component on the
you have to explicitly call page.isValid. There's a function you can say if page.isValid, and then if isValid forces server-side validation. If you don't explicitly call server-side validation through the page.isValid function, they don't. If they've executed on the client, they won't execute on the server unless you call that function, and that forces validation.
Basically, if you do only the client-side validation, it can be exposed.
Absolutely.
Oh, yeah.
That's true of anything. Any client-side validation is purely a business. It's aesthetically pleasing. It serves a business purpose. It has zero to do with security. Absolutely zero.
So if I do the client-side validation with the component, I should write some code.
Well, you can still call page. There's a method that you can call it page. If you query and say page.isValid, that forces server-side validation using the same components.
Yeah, but if it forces the server-side validation, it doesn't do the client-side.
No, it'll still do both. It'll still do both. Right. And that's the purpose of that function is to say validate the page, and it forces those components to do the proper validation.
I saw a hand right there. Those slides should be available. I believe there'll be a CD or something available for the conference. The slides should come with that CD. Do you guys have them publicly anywhere?
No, but in addition to these, actually there's a great, and these are actually probably went up about a month ago. Microsoft actually in conjunction with Spy Dynamics did 10 webcasts on security. So they're all like an hour, it's like 10 hours of this stuff.
Yeah, I think it's msdn. If it's the same place, it'll be msdn.microsoft.com/security.
Right.
There's ours and a bunch of other people's are out there. And actually, I think one of them was cross-site request forgery.
Yeah.
His is probably cooler than mine anyway. He tends to have cooler stuff than I do.
These are very rigorous because we are rolling out our carbon checkout applications on one of the major e-commerce sites next week.
Yeah, from the credit card perspective, make sure that your bosses know that if they do fail the PCI DSS security checklist, that they can get fined up to $500,000. And then
We have that covered on the server side. But
on the client.
That's the next Web 2.0 based, full AJAX-based carbon checkout application. Something we can learn from these slides to do more checking client side.
Yes, Peter?
I've got a web application, and I don't know what vulnerabilities it has. What can I do to get on top of that?
I think it's a combination of knowing what to look for and tools. There's obviously tools out there that you can utilize to check your site to see if you have vulnerabilities, but it's not going to catch everything. So,
Asking me if I like tools is kind of like asking if my kids are smart, because I wrote one of the scanners. But yeah, there's tools out there that can scan web applications to test them, and that's what we do. That will basically scan the applications to look for these kinds of vulnerabilities. And testing is important, whether you use our tool or somebody else's tool, or it's important to test. It's trust but verify, the old saying. It's good to code securely, but you also want to verify that you did it the right way.
And what we bring to the table is we actually do a hand analysis of the source code. So there's a dynamic testing tools that just look at the website that's compiled and it's out there ready to be surfed. And then there's at the other side of that coin is people go in and do an actual line-by-line look at the code and identify security issues and then turn that around and create a report.
So were you saying there was 2 minutes left? Okay, that clock appears.
Thanks.
It says 20.
Profoundly wrong. Okay.
Oh, okay, then that clock was way wrong. Oh, it's in time to start. I'm looking at the wrong countdown. Okay, last question, then we could take it offline out there if there's more. If there's any more questions. Yes?
This is kind of a different approach, but if you ever happen to notice a security vulnerability on someone's website, like you notice they're putting like a message in the URL of the index or whatever. Like I've heard lots of stories of people reporting that their loaders get sent after or whatever. Is there a standard procedure you want to tell someone that there's a vulnerability for someone?
The question is there a standard procedure to tell someone there's a security vulnerability on their site? I don't know if there's a standard procedure. Yeah, actually, I have a strong opinion on that one. This is my opinion. I'm not going to speak for my corporate employer. I believe that disclosing the information to the site is actually the first step. I do not believe in there's a whole topic among the hacker community about full disclosure. Again, it's my opinion. I have no problem with full disclosure after the site was fixed because I believe a lot in education. I want people to learn. But I don't believe in preemptive attacks where you go out and post, I found this hole and look at what I could do. Now there's the whole gray area. What do you do when they don't respond? I won't address that, but my opinion is go to the organization, notify them. Where you run into the gray areas is where you're trying to attack the site. That's where I think maybe lawyers might get involved. But a lot of times these get found by accident. You posted a message somewhere and it ran something funny, and you kind of scratched your head. And I always usually go right to the vendor. I mean, I would send an email to my competitor. I don't care because it's one of those things. The security of the web is like the responsibility of all of us in this room. Every site that's insecure doesn't just hurt that site, but it hurts the trust of the entire web. So I'd rather see a perfectly secure web and have all of us compete on the merits of what we could build than have, ooh, that site's insecure and I'm secure and I could take them down because I know that they're going to lose their customers. No, because all that does is create a general your customers just don't know what to believe in then. So as I said, it's not speaking as Microsoft, that's just my opinion. I don't know if there's any others.
Yeah, that's a slippery slope. I mean, general practice would say that, this is general. What people tend to do is get an anonymous account somewhere, email account, and send something anonymously saying, hey, I don't want anything from you, but please go fix this. Yeah. Hush mail. It's kind of the industry standard is you get a hush mail account and send it, as anonymous as you can. But nothing's perfect. It's an awkward situation because you want to help people, but then again, you want to talk to lawyers.
Generally what you'll see is when you do disclose the vulnerabilities, somehow marketing and PR get involved, and then legal gets involved shortly thereafter. So then after that, you should run away screaming.
I do want to say one thing. Microsoft, it's secure at Microsoft.com. If you happen to find ever a vulnerability on Microsoft, we have a very strong process where once it's submitted, you should get personal contact, not from marketing, but from someone to let you know we're on it, and you should be getting follow-ups and so on. And so we do have a process, and it's a very strong and rigid one where if something gets reported to us, we will address it. I've had things reported directly to me, and we take on them immediately. At least anything I find on Windows Live, if it gets sent to me personally, I address it immediately. I don't want my email address recorded, but if anyone wants it, I'll tell you offline.
And you can kind of engage the security culture of an organization. Like Microsoft's a very responsible steward in this community. But you can look at, like, say, other organizations that, you've seen vulnerabilities maybe published about them, and you can see their response, if any, and then kind of, gauge what you're doing from that standpoint. The ones that come back and say, oh, it's not a problem, we don't know what this guy was talking about, probably is not the person you should email going like, hey, I found another problem.
I think we're going to have to wrap up. I misunderstood our timing. I didn't realize I was looking at the time of the next session.
Great.
Thank you.